Hi friends, in this video I'm going to talk about monosaccharides. In my last video, I actually explained the classification of carbohydrates. That is, carbohydrates are classified into three places. The first one, which is the monosaccharide, and the second one, which is the oligosaccharide, and the third one, which is the disaccharide. But in this video, I'm going to talk about monosaccharide, and I will be focusing on the structural aspect of monosaccharides. That is the structural aspect of monosaccharide. That is the structural of monosaccharide. Then after that, I'm going to focus on the structure. After the structure, I will be focusing on the types, or simply let me just say examples of monosaccharide that we have. In my last video, I said monosaccharides are basically divided into two groups based on the functional group. And the first group is known as what? The aldehyde. While the second group is known as what? The ketone. Right? Now, the aldehyde group that we have and the ketone group that we have, this actually helps to divide monosaccharide into two places. Those saccharides that are actually falls on aldehyde part, they are referred to as aldose sugar. What I'm basically saying is that the monosaccharide that has aldehyde functional group are commonly known as what? Aldose sugar. They are referred to as aldose sugars. While those with ketone functional group are known as what? Keto sugars. Or simply say ketose sugar. Right? Now, that's another point that I want you guys to understand. Now, we have different types of aldose sugar ranging from the 3 carbon atom, which is the case of glyceraldehyde, and that of 4 carbon atom, which is actually the erythrose, or you can still have another one which is known as the triose. It's just THREOSE. That's triose. It's also 4 carbon atom. Now, we have those of 5 carbon atom that actually have aldehyde functional group, which is the case of what? Of ribose. We can have it to be ribose, and we can have Arabinose, we have xylose, we have lysose, and so on. Then those of 6 carbon atom, we have it to be what? They are actually called exosugar, and we have the common one, which is what? The glucose, right? Then we have that of what? Of 7 carbon atom. That is those ones that contain 7 carbon atom. They are also, we have many of them, right? We have the case of pseudoheptulose, which is under keto sugar, right? Now, 3 carbon atom of aldose sugar, we have glyceraldehyde, and that of keto sugar is dihydroxyacetone. Then that of 4 carbon atom, we have that's ribose. I think ribose is actually 5 carbon atom, right? But that of 4 carbon atom, we have the case of xylulose. Then here as well, still under this keto sugar, we have the case of 5 carbon atom, which is called ribose, right? We have ribose. We have fructose, which is 6 carbon atom. Then we have pseudoheptulose, which is 7 carbon atom. Now, these are the types of monosaccharide that we have. There are more than this actually, but these are the types that we have: 3 carbon atom, 4 carbon atom, 5 carbon atom, 6 carbon atom, and 7 carbon atom. So these monosaccharides are the ones that are joined together by glycoside bond to form disaccharides. Then if disaccharides comes together, we have pack of monosaccharide. They actually serve as building block to more complex carbohydrates, which is referred to as polysaccharides. So here, let's simply move to the structure of monosaccharides. We have different types of structure depending on the projection and actually what we actually want to do when it comes to monosaccharides. Maybe, for example, we are focusing on the reactions of monosaccharide, or maybe we are focusing on the stereochemistry of monosaccharide. We have the first one, which is commonly referred to as the Fisher projection formula. Fisher projection formula, and we have the second one, which is referred to as what? As Haworth projection formula. Now, Haworth projection formula is actually applicable for carbohydrates, or simply let me just say monosaccharide that has 5 carbon atoms, starting from 5 carbon atoms. That is, Haworth basically postulates its structure based on the furan and also pyran form. So the structure of Haworth is based on furan and also what? Pyran form. And we know that furan is actually what? 5 carbon atom, while pyran is what? Is 6 carbon atom. Now from there, let's simply move to this side. As far as Fisher is concerned, for glyceraldehyde, which is the 3 carbon atom for the aldose sugar, the structure is drawn as this. This is 3 carbon atom, which simply represents that okay, this particular monosaccharide has 3 carbon atom and it belongs to aldose sugar if I added the functional group at position 1. Now look at this. The functional group is here, which is aldehyde functional group. Then I'm going to have OH here at this side. Then I'm going to have hydrogen at this side. Here as well, I'm going to have OH here. I'm going to have hydrogen here. And also what? Hydrogen here. This is basically the structure of glyceraldehyde, the 3 carbon atom. But let's say I want to draw dihydroxyacetone. What I will basically do is just for me to just interchange it, not just for me to switch the functional group. The functional group on position 1, I'm going to put it on what? On position 2, right? That's what I'm going to be doing. Now look at this. I'm going to put it on carbon number 2. Look at it. So here I'm going to have the functional group to be here. Then here I'm going to have I'm going to fill the rest of this with OH. I'm going to have OH here. And if you look at this very well, the bond of carbon is not complete, right? This is 1, 2, 3. Then I'm going to have another hydrogen here, which makes it complete, right? So that's just the case of what? Of dihydroxyacetone. And you can also name it using IUPAC naming, right? You can name it using IUPAC naming. So here you're going to have 1, you're going to have 2, you're going to have what? 3, right? Now if you look at this very well, you are having hydroxy group on position 1 and also what? 3. So this is basically 1, 3 dihydroxy. Then I'm having 3 carbon atom, which is what? Which is prop, right? So I'm going to have propan 2-one. That is actually the name. I'm having to 1, 3 dihydroxy propan 2-one because the carbonyl compound is found what? On carbon number 2, and there is no trace of what? Of double bond. Everything is single bond all through. So I'm having propan 2-one. Then from there, let's move to 4 carbon atom that we have. The 4 carbon atom that we have, that is the Fisher projection formula for 4 carbon atom. It's very, very simple. You just have to calm yourself down and just follow the orientation of the diagram. You get it. Now, for the 4 carbon atom that we have, as far as aldose sugar is concerned, I'm having it to be, we have the case of, that's erythrose, right? Erythrose is actually a 4 carbon atom and it belongs to an aldose sugar, right? So it is an aldose sugar and it has 4 carbon atom. Then I'm going to have carbon here, carbon here, carbon here, and also what? Carbon here, right? So from there, the functional group is only going to be what? On carbon number 1. Since it is an aldehyde, then it's very, very important for you to just put the what? The functional group here first. Then you move on to carbon number 2. You feed here with what? OH. You feed here with what? OH as well. They're going to have CH is here, H is here. They're going to have what? OH here, right? Then you're going to have hydrogen to be here and hydrogen to what? To be here. Now that's just it. So now in this kind of scenario, we just have to then name it, right? We already know that the normal name from this kind of compound is 4 carbon atom. It is called what? D-erythrose. And I'm going to explain the reason why it is called D-erythrose. This D is basically explaining the orientation of what? Of the hydroxy group, that is of the terminal hydroxy group. And terminal hydroxy group is found here at this side. The orientation is on this side. Look at this, is on this side. That shows that whenever the orientation is at the right hand side, you call it what? You call it D, which is dextrorotatory. Then, or you simply say devorotatory. If it is found on left hand side, you call it what? Levorotatory. That's actually the orientation of monosaccharide, right? That is, whenever you have it on the right hand side as this, you call it D-erythrose. Whenever it is on the left hand side, you call it what? You call it L-erythrose. But I'm still coming there and I'm going to explain that one as well. Now let's go ahead and name this and name this using IUPAC name, right? Let's name it using our IUPAC name. Now, naming this kind of compound using IUPAC name is very, very simple, just your normal naming as well. So let's go. So from here, we're having carbonyl compound here, right? Then we're having another OH here, 1, 2, 3, right? So from there, we are going to number our atom. We know that this carbon atom here is actually what, 4. Then here we have what, carbonyl compound on position 1. So 4 carbon atom is actually what, but, right? So here we simply have butana, or you simply say butan 1Ha, right? Then from there, we are having hydroxyl on position 2, on position 3 and 4. So this is basically 2, 3, 4, right? Then what are you having? You are going to have trihydroxyl, right? Butana. 2, 3, 4, trihydroxyl butana. That's basically the name of this guy, and the common name is referred to as erythrose. Exactly. So that's just it. Then let's move to the 5 carbon atom. And the most popular 5 carbon atom that we have is actually the one that is found in the structure of RNA, which is the ribose sugar, right? Is the ribose sugar. So I'm going to draw our ribose sugar in form of the Fisher and also the what? Awort. Don't forget that the Awort is actually the what? The cyclic form of what? Of monosaccharide. And one thing about it is that it basically shows the reaction of what? Of monosaccharide. That's why we always use what? Awart's projection formula. But if you want to show the stereochemistry of monosaccharide, it's better you use what? The Fisher formula. Now look at this. Let's move to what? To ribose. Now ribose is actually an aldose sugar as well. It's an aldose sugar. Ribose is an aldose sugar. That sugar is going to have the functional group on what? On carbon number 1. So these are carbon number 1. You're going to have the functional group here, right? Aldehyde, right? So 1, 2, 3. Then we're going to have another one connected to what? Another carbon here. We have a carbon here, and we have a what? A carbon here, and also what? Carbon here. This is 1, 2, 3, 4, 5. Now we have to what? To place the orientation of what? Of the hydroxy group, right? So